Awesome. Okay, so hi there. I'm Christian, developer working in Variant as well as a lot of others here. I'm going to talk about testing, and I changed the title of my talk last evening, which was a huge mistake because the video intro didn't have time to change, obviously. I didn't tell anyone, so that's a good idea. I'm going to be talking about testing, the general approach, maybe mindset around it, but also tools and patterns and everything. And I'm also going to, like, a huge principle I'm going to go back to in my talk all the time is that tests might actually impact your solution and code base and how you work in ways you do not necessarily imagine at first. And there'll be code slides, no IDE here today, but it'll be in C#, just be forewarned. But I think the principles here will stay true no matter language or framework. All right. But first I have to get you to care about the subject. And I'm sure a lot of you didn't wake up this morning and think, do I need tests in my solution? But this is a fundamental question in my mind. It sort of underpins the premise of my talk. Because writing tests takes time away from doing stuff you might rather want to do when working on solutions. That is writing code that actually does stuff instead of just verifying it. And I've written a lot of tests in my career, and I have to admit I don't really enjoy it at all. I sort of compare it to jogging in some sense, which I do not enjoy either. I hate the act of jogging. I hate being in the act of jogging. It feels really good to have finished a jog. That part is great. And of course, I enjoy the long-term health benefits of actually taking care of myself. And I think testing is sort of like that in some sense. It is sort of like an investment in the long-term health of your solution. So that is what testing is. But like with exercise, I guess, we humans tend to have sort of a maximalist mindset in some sense. At New Year's Eve, you probably tell yourself that this year I'm going to run 3 times a week and, I don't know, only eat broccoli for breakfast or something like that. And then you do that for a couple of days, maybe some hours, and then you just go back to the old habits of doing exactly what you used to do. At least that's how I work. And thinking about that, I often go back to this quote by Guillermo Rauch. He is the CEO and founder of Vercel, the guys behind Next, which we heard a lot about today. And the quote is, write tests, not too many, mostly integration. And I think, like with exercise, and this is getting to be a tired analogy, so I'll drop it soon, but like with exercise, the data shows even a little bit is infinitely better than none at all in terms of health. So I think if you have just one integration test, for example, if you're building a website or API or something, and all that one test does is check in a browser or anything like that to see if anything rendered at all, that is the most important test you write in the lifetime of your solution. Because how many occurrences of downtimes or just general derps wouldn't be avoided if we on each commit just check, is anything there at all? And I work with solutions that sort of run contrary to this, solutions with hundreds, even up to 1,000 tests. And I'm not necessarily saying that more is better. I sort of want to say the opposite in some ways. But I am saying tests have saved my butt more times than I can count. So that is the general principle around tests. But what we often forget about tests, even though we don't really enjoy doing them, and only if we have to, if we do them, they do impact our solution in ways we might not necessarily think of at first. So this is a visualization I grabbed from codecm.com. Bottom left corner is the link. And the guy behind that is a guy named Adam Thornhill. And I'm not sure if I have any Swedes in the audience, but he is a Swedish guy from Malmö who does a lot of cool work, I think at least. He does a lot of work in analyzing complexity of code and change coupling and stuff, which might sound boring, but you get awesome graphs like this out of it. And what this shows is it's a visualization of the React codebase, the React framework codebase by Facebook, the official one. And it's showing a hotspot analysis of files in that codebase. So basically what it's showing is the larger the circle and the redder it is, the more often changes happens in that file in the lifetime of sort of the solution, from analyzing Git and stuff like that. And what you can do with this visualization as well, you can hover over the different files, and the yellow lines point towards other files that normally changes along with the file that you're hovering over. And the blue circle sort of is modules, packages, which those files are in. And if you take this example, for example, here I'm hovering over React fiber hooks. And if we zoom in here, I was at a talk several years ago now, I think by Adam Tornell, the guy behind this. And he talked a lot about which types of files normally changes together. So I'm hovering over React fiber hooks, and you see 5 other files being pointed to with the yellow lines. And of those 5 files, 3 of them are test code files. And this pattern will show up again and again if you look at different files in this solution, but this is a unique pattern to the React framework codebase. Very many professional codebases out there has this pattern. And the pattern is, in essence, that test code tends to become sort of viral in your solution, in terms of changes, that is. And you may notice as well now, as I said, the files being impacted is not necessarily the same files that are inside the module as the file being changed. So not only are they viral, but the changes and the sort of coupling spans across different parts of your system, which I think is kind of interesting. And this is not necessarily something you think about from day to day when you do your work, because nobody will ask you, normally at least, to do some sort of change in your testing code. Like product owners won't open a ticket, please change this test. They will normally ask for big new features or more likely a button, I guess, in some, that's what they usually ask for. And that is sort of the point of my talk as well. Testing is absolutely something you should do. It has outside benefits in terms of how little it requires. But at the same time, test code becomes viral in your solution. And this is something you have to think long and hard about when you architect your test code, which is why I recommend how you look at how you split up your test code, what patterns you follow, and even what you test. That becomes increasingly important. So this is me quoting myself, I guess, but I like this principle. If you write test code, you should architect it as if it is code running in production. Because in the long term, you'll sort of save yourself a lot of work that will become invisible to the people who ask you for new buttons. That's my pitch for why you should care at all. And so I've talked about why. Now I'm going to talk about sort of the what. And we'll have many code slides coming here. Again, C# code. And I'm going to introduce 3 different files or types here, which I'm going to refer back to all the time. And use to sort of show the different patterns and exemplify the different ways of thinking about testing that I think you should do. So to begin with, we have the dependency, a repository. So basically what this is in C# is a contract. An interface is a contract. It tells you something about how something else should look, how the actual implementation of the interface should look. It has no running code or behavior in that sense. And this is what I call a I-user repository. A repository may have a database behind it or some other backing store. You don't really know. That's the sort of point of the repository, or at least this contract. And this is the thing we're going to sort of be changing during my talk to show the different ways you could test something else, which is this. It is the account service, and here you actually see real behavior. This is what you would call in testing the system under test. And I know this is naive and simplistic, that's sort of the point, so it doesn't take up several slides to show it. But this is the thing that uses the repository to do its work. So this has behavior. And it exposes two things basically, the login and the register method. The register method uses the repository to add the user by email and password. And the logging basically gets the user and checks, is the password the same? If so, you get the user back and you're logged in. This isn't real code, it's just to exemplify the different ways of testing. And last is the test class. It has one method, or one test case, or fact, as you can also call it. Basically, it just checks. With the account service, after I've registered the user, can I log in with it? If I got a null back, then it didn't work, the test is red. So the thing we're going to do here is just to test, is the account service behaving correctly? And we're going to explore the different ways of doing that during this talk. But as you may notice, I'm not actually sending in a dependency here, I'm just sending in a null. And that is the thing we're going to have to fix. And to do that, I have to talk about test doubles. There is a lot of theory in this talk, obviously. I'm noticing now while I'm actually running through it. Okay, so test double, a double here is not the same as the data type double. It's not a number type. It is something you build in order to replace dependencies in your solution. And the Wikipedia definition here is that a test double is used to satisfy a dependency so that the test code need not depend on production code. So in other words, the repository is sort of the thing we're going to replace with the test double. And while this does not exactly contradict my previous code, it does sort of run in conflict with it. So that's also something I want to explore during this talk, because it sort of impacts the mindset you have when you test and when you write test code. But to get back to test doubles, there are several categories, but the main three ones that I want to focus on here is stubs, mocks, and fakes. And we developers, we tend to use this in sort of daily speech. We tend to use them interchangeably in some ways. Like you fake the repository, you mock the service or whatever, you know? But in sort of testing theory, they mean explicit things. And they're sort of going to, my reason for picking these three is they're sort of going to conceptually build upon each other in level of complexity, sort of. So stubs here is the easiest one. Its definition is stubs are implementations that return static values. Short and sweet. And I mean, the implementation as well is short and sweet as well. So I've taken the repository contract here, and I've implemented a stub. So now we have a class. But the thing here is that this has no dynamic behavior. It's just a static sort of implementation that you could argue that the email and the new GUID gives it sort of dynamic behavior, but for all intents and purposes, this is a thing that really does nothing. It does the bare bones necessary to be able to compile the code. So you get a user object back with get user by email, and add user, again, does absolutely nothing. And the way you would sort of use it then in test code is like this. So you just construct it, and you send it into the account service. And the benefit of stubs, to give it some sort of positive upsides, is that you can reuse the same implementation across test cases if you want to. But the downside is they're so specific and static that they have no real behavior. You're just assuming the way they're going to be used when writing the test code. And so the only reason this works here is that when I log in, I use the same password as in the previous slide, setting it statically to password. That is the only reason it works. So if I, for some other test case, wants to try another password, this wouldn't work. But it does impart real behavior on the account service, because that is the thing actually checking the password. So here we are very specifically testing on the implementation details of the dependency instead of how it should behave. Not sure if I'm making myself understood there. But moving up in levels of complexity, we have mocks. And the definition is, can dynamically simulate behavior and be used to verify its expected usage. I think code here is also going to help better than trying to explain it with words. So going back to the old base test case here, if I make a mock, and a mock is something you normally do with a library or some sort. You don't really write them yourself, or at least the dynamic part of it. But what it allows me to do is say, I can say I want a mock of the iUser repository, and when someone calls the get user by email on that, I want with any string really, I want this user back. And at first glance, this might seem like equivalent to a stub, because it seems sort of static in the sense that, well, you get the user back with these specific fields, but it's dynamic in the sense that you can actually do this per test case. So you can sort of dynamically, per test case, define the behavior that you want the mock to have. And that makes it more dynamic than a stub. And further down in the test code, you're able to verify its expected usage. So you can sort of check the implementation details of it. You can check, did something called the add-user method? Did something called the get-user-by-email method? And the mocks are great for that. So it's sort of a second assertion layer also in terms of the dependency. And I'm sure there are many people who used mocks in this room and really enjoy them for this reason, because it's really easy to quickly get sort of started defining behavior per test case and just setting up things how you'd like it per test case. So it seems like a silver bullet, but I have to sort of compare all the different alternatives here. The last in the list are fakes. And the definition is fully functional, or relatively, I think is the keyword as well. Relatively fully functioning implementations for testing, for example, an in-memory database. I'm not talking about SQLite, by the way, when I say in-memory database. So a stub, or rather a fake, is just a stub taken far further, really. So it's an actual implementation that you build, but with more complexity, because instead of statically doing stuff, you're actually dynamically doing stuff. You're sort of faking the fact that there is no database really running under the hood there, but you're sort of masking that through a fake implementation. So what I've done here is I've added a users list, and you're actually operating on that users list in the side of fake. So when I get the user, I actually try to get it from the list, and when I add it, I actually add it to the list. So it has real behavior, but is it production behavior? That's another question, and we'll get back to that. So these are the three options, and I want to sort of compare them. And when I'm saying it's the three options, it's the three usual options people go towards when they want to write test codes. And I want to compare them and upsides and downsides, etc. a bit. And the sort of quickest, easiest point to make is that the last normally has some sort of internal state. The first two does not, which might seem me contradicting myself, because didn't I impart some sort of state-ish behavior on the mock while setting it up? But I think that's a bit pedantic, because you can't really reuse and expect the same sort of behavior then across different tests. So to my mind, it basically has no internal state other than what you defined then and there for the test. And the downside then is that you can't really impart any side effect either, because it has no internal state. And to go one further, I find sort of stubs to be so an inferior option here, so I'd just like to even drop it from the list and just go on with the other two, because there's so many downsides to use it unless you have no option at all. But another downside of mocks is that it tends to make your code more specific and brittle than maybe you'd like. Which seems maybe weird, because you can do what you like per test case, right? But what makes it specific, again, is that we're testing on the implementation details of the account service and the dependency, the repository. We are testing on how the code lines are written right here and now. That is what we're testing on. You're presupposing, and that is sort of the bad assumption then maybe, that code will never change. That sounds like a ridiculous statement when I say it in a room full of developers. So, and And we're also presupposing sort of that, not even taking the account service into account, that we, wow, fun. What if the dependency changes? Or the actual contract changes? What if, for example, we take the user repository and we want to change that? It's no longer get user by email or add user with string and password. It's get user by ID and add user with the whole user object, because the user object grew during the lifetime of the solution, and we have so many more fields we want to save when we add the user. Which completely changes the premise, the code that we wrote in the test code, which it is built upon. So if I take this code, I have to rewrite it to instead mock and set up the add user method in another way and the get user by ID now. And as well, I have to go down the list and I have to change how I verify the expected usage as well on the mock. But do you see where we are now? This is where we are. We're back here. Mocks are a tool with strong virality in your code base. And what I just changed might not seem like a big deal, but you have to multiply that by the number of places you use mocks, and especially mocks around the same dependencies. And that can be very many, especially if you break up your solutions in the way I've done now and test them sort of in small isolated components. So I'd then ventured to say that mocks are and makes tests specific and brittle and subject to sort of continual change. And at this point, it might seem with 3 red signs there and 1 green by fakes, I'm pushing you into the direction of fakes. But they have their own downsides as well, of course, because if we rewrote our previous fake to the new contract, and we sort of, what we're trying to simulate here, right, is, again, that there is some sort of database or some sort of backing store for the data that we operate on. But as you may notice, when I add the user, for example, I'm not checking if another user or if the same ID exists already inside the list. That is behavior you would expect from a database. When you try to add a row with the same primary key, you will get a duplicate primary key exception or something like that. And that is, of course, easily fixable in some sense. I'll just use a dictionary here or whatever. But the reality is, services that we use, and especially dependencies that someone else has made, which we sort of just want to sort of abstract away, they are complex in very nuanced ways. It's extremely hard to write mocks or fakes, for that matter, especially fakes, that can properly simulate the behavior of the services that we use. I like using fakes for very simple things, but it is such an uphill battle to do this for different types of services. For example, databases with different behavior in SQL query languages as well. Which is why I wouldn't even recommend using SQLite, for example, in development and then use another database provider in production. The nuances are too many. So, trying to fake proper services is a continual uphill battle, and the hill just gets steeper as you start upgrading the dependencies, and the way you faked it before is no longer valid. So at this point, it may seem that, okay, we have no options at all. We can't write test code. Of course we can. But the examples I've shown here, and it's on purpose, have been broken up in very isolated small parts. And then I have to go back to this quote. Because we're checking on specific implementation details and maybe behavior in small tests. But if we take this philosophy, this tweet at heart, you shouldn't break up your tests into small batches. You shouldn't isolate components, because it has diminishing returns, both in invisible work and management, but also in actually testing real behavior. There's a lot of work. So, to my mind, you should test more system-wide behavior and hopefully the important application flows. So, write less tests and tend towards integration. And because this will then sort of push you into the direction, when you think system-wide, into architecting your test code as if running in production. If you take this also to its logical conclusion, the answer becomes clear. Don't try to fake or mock or sort of rebuild the world by yourself. You should just test with production equivalent services or dependencies. But what does this mean? Does it mean, okay, I should start like provisioning databases in Azure and using that in my test? Or what is the answer here? And, well, sorry, went back and went forward, and there we are. These are good principles to follow when you do tests. Reproducible and isolated environments, so you'll sort of end up being able to run the tests anywhere, both on your machine and the CI/CD pipeline. And deterministic test runs. In other words, as Mikael complained earlier today, if tests are flaky and they tend to go from red to green without the code having changed, that is obviously a problem. So that is not a situation you want to be in. But I think the most important bit here then is do not use shared infrastructure, because that is infrastructure that by its nature will change all the time as well and become flaky and also make it more difficult for you to reuse across different environments. And people who know me well will know where I'm going with this, but to my mind there is a logical conclusion here as well, and that is using test containers. People are humored in the audience, I hear, because I love test containers. People know this, but for those who don't know about it, what is it? There are many different ways it's pitched on the website, but the way I like to think about it is that test containers is a library for management of Docker containers from code, which might not sound impressive sort of by itself, but it has a lot of subtle strengths in use. It allows you to test with real dependencies. So it provides you with throwaway, lightweight instances of databases and services and stuff you normally use. And because it uses the Docker host as a foundation, which pretty much everyone has installed today, even on CI/CD pipelines, you can pretty much run it anywhere. And it supports many different languages: .NET, Java, Rust, Node, Go, you know, take your pick. And here I have sort of just to demonstrate that the ecosystem is pretty rich too. They have a lot of pre-built modules that allows you to get like quickly started with any type of service that you normally use. But you're not sort of limited to this. You can run anything you want, really, as long as it's a Docker image, even stuff you sort of also have as Docker images. And this makes it sort of easier to get started with them and configure them, etc. And I'm not going to dive a lot into the architecture of test code and etc., but this is sort of the basic life cycle of how you would use it. So you sort of provision it and start it up in the start setup part of your test code. Then then test containers sort of takes the job of provisioning all the things it needs or the containers needs, like network and ports and volumes and everything it needs to run. Starts them on your Docker host, and then they are available for when you run your tests. But the nice thing about test containers as well is there's a lot of built-in automatic in cleaning up the resources after the test run. So when test containers notices that the test run is done, it will kill the containers, it will remove them, it will free up all the resources, and basically it be like it never happened in some sense. The perfect crime. And this gives you the principles I talked about earlier. It gives you reproducible environments everywhere. It gives you isolated environments that is only for the test run and is gone after it's done. It gives you deterministic test runs as well, because you can provision these containers with exactly what you need then and there to enable the same scenario every time. And it also then gives you, of course, production equivalent dependencies and imparts real behavior to when you're testing. So I'll just show a quick code example on how to use it. So instead of faking, mocking, stubbing, whatever, the repository, just use the production version of the repository, which uses the actual database. That is sort of my point. And yes, again, naive, simplistic, not good code, but it shows it in principle, I think. And then in the test case, you can use test containers to set up, for example, a PostgreSQL database, start it, send in the connection string into a database context, give that to the repository, and then give that in turn to the account service. And the point here is then that all of this infrastructure, all of this behavior, all of these dependencies are production equivalent. You're running with the exact same code that would run in production. There are subtle differences, of course. I'll give you that. If you're running, for example, a managed database in Azure or GCP, that might not be exactly to sort of the byte, the same thing that is running in the test containers, or the networking might be different. But it's production equivalent, and that is the principle here. And I wouldn't really write tests like this either. Again, I think it's too broken up. I would instead scope this up to be more system-wide. Try to hit some other point. It doesn't have to be end-to-end in the UI. It doesn't have to be necessarily either in the API, but at some level that tests wider than if you go component by component. .NET Aspire for .NET developers is another okay, cool option, which is getting better. It's not quite there yet, in my opinion. There's a lot of sort of work in getting it to run tests, but it works. So it can also provision up services for you, and then you can test on them, almost like test containers. So I've implemented that in one project, and it works totally fine. It'll probably get better in like a year or so, I guess. So so stay tuned or something. All right, so just to close up, after sort of giving concrete tips on tools now and how you should think, I want to also impart some more tips, or rather just to summarize the tips in terms of the mindset you should follow when doing tests, and what I think is important with them. And the first one is less is more if you test the right things. If you don't test the right things, then less is bad, obviously. But the right thing then is to increase the scope of your tests, which I've tried to hammer in as many times as I can. Like, for example, spawn your website in a browser and just look, is anything there at all? If you have all the infrastructure behind that, that is a great test. It's an awesome test. Everyone should run home right now and write that test, because it's awesome. But I hope you go further than that, of course. Test behavior rather than implementation. Test what you want the thing to behave like, not what the lines of code are. If you have to presuppose how the lines of code are in order to set up your test, that is the wrong test, because you get a lot of pain down the line. And to be clear, I'm not saying you have to test everything like a black box. Like, this thing you built, the code base, is not something you have any knowledge about, so you're going to approach it like it's like a strange animal, and you have to sort of prod it to understand how it works. You can, for example, check the database. Did this row, was this row inserted when I did this thing over here? That is a fine thing to do, because it doesn't cost you a lot in terms of the virality and changes and code change coupling in the code. Your database should probably change maybe a bit more often, but less often, or ish as often as the API you're sort of approaching here. So, but the things between them, they change pretty often, even though we don't think about it. And last but not least, I have to hammer this home: tests with production equivalent dependencies. It's really important. There are room for the other tools I've sort of been dunking on this whole talk. But don't reach for them first. Even though they feel productive, even though they feel sort of nice to work with, they'll cost a lot down the road, especially if you overinvest in them. And that's my talk. Thank you for coming. Hope it's been of some help.